Hey there, welcome back to my channel. Let's continue with our episode. In the previous episode, we have worked on our use case layer, right? So right now we have our entities, we have our use cases, and we have our presenters also. Presenters we can consider as a kind of HTTP layer, which is already we have added handlers to provide the HTTP response, right? So we have only one layer left, that is the blue one, where we need to provide the database access, right? So let's try to work on today in the database side, right? So at least while we are going to create our user, it has to be able to create the user on the database, and somehow we need to get it back also, right? So let's try to focus on that part, right? So let's jump into the source code. So here in the user service, we have added all the required functions to handle the business logic, right? And we have fairly hooked up with our user handler as well as. On the time of the instantiation of the user handler, we have created our user service right here and injected to that specific handler with the help of our user handler struct, right? So now you can see we have all the handler functions have the access of user service. So it can get the data from the user service. Perfect. Let's jump into database integration part. To integrate the database, what we need to do, we need to create a couple of files inside this repository directory, right? Which is already we have created on the time of the create the project, right? Inside this internal, right? But as of now, we don't have any database server right here, right? So we need to spin one database server here. So to spin the database server, you can install the database server in your local machine also, or you can use Docker container also. In our case, we are not going to install the database server in local machine. Rather, we will be going with the Docker flow, right? So let's try to create one file here. This is going to be a Docker compose file, Docker compose.yaml, right? Here I will add some necessary code to spin our database server quickly. So now this is our Docker compose file, right? So here we have created one service that is called Postgres, and we are using PostgreSQL latest image, right? And we are saying restart always. If anything going to be wrong right here, then restart always, right? So these are some essential environment variable that is required in order to spin our PostgreSQL container, right? So these are the variables, Postgres user, password, and DB, right? And you can dig deeper a little bit on the PostgreSQL official image. What are the environment variables are available to bootstrap it, all right? You can look at right there. And this is our port. 5432 is the default port for PostgreSQL. So this is our container port number, and this is our machine port number. So in my case, this port is already been occupied, so I'm going to change it to something else. As an example, this port is available as of now for me. So this is the volume where we will be store our container data, all right? So this is the container path where data will be live, and in our local host machine, this is the path exactly where we will keep our data, right? So at the end in the volumes, we are defining what type of driver we are going to use to store in the DB volume. So that's all from this Docker compose file. Perfect. So now our Docker compose file is ready. We need to spin this Docker compose file, right? But how we can spin it? We need to install a couple of prerequisites to do that, right? So let's go to docker.com/product/docker desktop. So you can install Docker from docker.com also, right? Or maybe you can install Docker desktop from here. So in my case, I'm using Docker desktop Mac for Apple chip. This is the one which is I'm using. Maybe in your case, whatever the operating system as per your machine's configuration, you can download it and install it, right? So once you are successfully installed, you can see this Docker desktop application, or maybe you can just go ahead and open this Docker desktop application. In my case, I have already been installed. So let's go ahead and spin our Docker compose file, right? So to spin the Docker compose file in the background, we need to type a command that is called docker compose up -d, right? -d stands for detach mode, right? Docker compose up -d. Right, so now it is created, right? And it is running. So our Docker compose file created one container for us, right? So let's verify these things by visiting the Docker desktop application, right? So in my case, I have already opened that one. And now you can see this is the container it's created, right? And if you expand this container, you can see this is the container that is called Postgres 1, and it is spinning at the 5428, right? So this is the This is our machine port number, and this is our container port number. All right, so now let's go ahead and connect this database server with our database client. You can use any kind of database client as per your convenience, but in our case, for this tutorial only, we are going to use Table Plus, right? So here in the Table Plus, click on this plus sign right here and select PostgreSQL here and click on the create, right? Now, here we are going to add the name of this specific connection that is called, let's say, online go online series, online shopping series, right? So now here in the host number, we need to put our local host, right? And port number will be the same port number that is we have defined right here in this Docker Compose file. You can see this is the port number, right? And let's try to copy this database name from here, right? And port number will be 5428, right? And 5428. And username will be root. You can keep any name right here in this Docker Compose file. That is the specific name, and the password you can utilize right here, okay? So let's try to make it simple because this is gonna be spin from our local host only. For the production server, we should not supposed to keep this kind of the short name. We should at least we need to keep a kind of like strong name right here for user, password, and the database also. And in that case, we can store all these secrets in our maybe secret manager or somewhere, right? Potentially we can store in the GitHub or maybe AWS secret manager as well as, right? Let's get back to here. Right now in the database, like we are going to store the name of the online shopping. This is perfectly fine, right? And now let's try to test this connection. Now you can see we have the green marks, all the fields, right? So that means our connection is successful. So let's try to click on the connect, right? Now you can see we have connected correctly, right? But we don't have any table. Absolutely, we have not created any table, right? So let's go ahead to the source code and we will be adding some kind of table right here, right? So let's try to close this window here, right? And I'm gonna close everything from here, close all tabs, right? Now let's discuss about the database integration, right? To integrate the database, we can follow multiple approach, right? There are different ways are there where we can hook up the database, right? So one is like without any kind of ORM, right? With the help of some kind of native library, right? So in our case, we have already spinning the PostgreSQL server. So definitely we can go with the PostgreSQL native plugin. But other way around, we can use some kind of the ORM also, right? So I have already published one video where I have explained pretty much in a good way when to use the ORM and when not to, and what are the pros and cons, and how we need to consider the uses of the ORM and the native SQLs. So in this application, we don't have any kind of complex operations right here. So we can fairly consider ORM for this one. While it comes to the ORM selection, definitely I'm gonna say like, let's use the Go ORM, right? Or maybe you can say GORM also. The O is hiding right there. That's perfectly fine. So let's go with the GORM, all right? So click on the docs, right? And you can see there are kind of few steps over there where we can see how to install the GORM for various drivers, all right? So in our case, we are not going to use the SQLite, we are going to use PostgreSQL. So we need to install that particular driver as well as, and it is very nicely documented. You can go ahead and explore it, how to use and what are the advantages are there, right? In the practical way, in everyday life, I'm always using the GORM and some native SQL also. Now let's install GORM for our project, right? GORM.io/GORM. Yes, it is installed. And then another package we need to install that is called driver. Driver, in our case, we need to install our PostgreSQL, right? So that is we need to get it. So let's try to go get it. Go get -u GORM, and here we need to put the driver and Postgres, right? So now we have a Postgres as a driver as well as. So let's go to the source code and we'll be going to integrate this GORM for our project, right? So let's try to close this terminal window from here. So inside the source code, let's go to API here and click on the server, right? Here in the server.go file, inside this start server function, right? So right before kickstart of the HTTP server, we need to connect with our database, right? So let's try to connect our database. But right before that, we need to have the proper credentials as well as, right? Which is we have been used for our database client, right? The similar way we need to add it right there. So where we can add it, let's go to the app config, right? Perfect. So here in the app config, we need to add our database configuration settings, right? So how we can add it? So the way we have added the environment variable, just like server port, this similar way we need to add it, right? So let's try to add that one. So in terms of database URL, what we can do, we can keep a kind of variable name, just like DSN, right? DSN stands for data source name, right? This is going to be string. And let's try to assign this DSN right here also, right? While our setup env is going to be called, at the time it will be load all the env variables right here, right? So as you can see, we have a particular check for that one, right? So and the similar way we are assigning this HTTP port also by looking this HTTP port variable in the .env file, right? So let's try to do something like similar, just like HTTP port. In this case, what we're gonna do, we'll be assigning like the SN, and we can say os.getEnv. And here we'll be put the key name. The key name will be our SN, right? And we can do a check also, just like similarly we do for our HTTP port. So let's try to grab this piece of code from here and add it right there. And instead of this HTTP port, this is going to be DSN. Perfect. As of now, we don't care about these error messages right here, right? So once all the environment variables are landed here, then definitely we are going to implement some kind of advanced plugins right here in order to loading all the .env file or maybe environment variables. Then we can handle all the errors in one single spot, right? Perfect. So now our DSN is right here, and we are reading the environment variable also here, right? So let's try to add this DSN here while we are creating this struct. So DSN. This is going to be DSN. Cool. But one problem is here, because we have the HTTP port, but we don't have the DSN in our .env file, right? So let's go ahead and add this DSN in our .env file. So here, go to .env file, and right after this HTTP port, we are going to add that one. So here, this is going to be DSN equal. So here, right after DSN, right after this equal parameter, we can put all these variables, just like whatever the required credentials for the database, we can put it right there. So first credential will be just like host, right? So host will be 127.0.0.1. And after that, we can put a space, because this is how .env files are working, right? This is determining like whether we have a space or not. And then after that, it is try to get that specific key by segregating the equal sign. Right before the equal sign is the key, and right after the equal sign is the value. This is the way the .env files are working, right? So let's go ahead and add one more. This is going to be our user. User will be our root. And after that, it will be our password. And password will be also root, right? Then it will become our DB name. This is going to be DB name. And DB name, let's go ahead here in Docker Compose file. Let's grab this, right? Copy and come over here. This is our DB name. And then after that, the port number, let's give a space here. Port number will be 5428, right? So let's try to make sure. Yeah, 5428. So in your case, maybe 5432 also will be, because in my case, that specific port is occupied already. So now one more thing we need to do, that is called SSL mode will be disabled. Yeah, this is the parameters going to be needed just for connecting our local machine with the database, right? So while it comes to the production, then we should not supposed to disable it, right? So can you see our DSN is, this is our DSN, and this is the key, and this is the value exactly, right? And value also has a kind of key here, and separated by equal. Can you see there is a kind of spaces there in each key, right? So this is how DSN key is defined in .env file. Right, so let's go ahead and implement that one. Now our DSN is ready. Now we can get it from our server, right? So let's try to close everything from here. This one, excluding the server, right? So let's try to grab all the DSN stuff right here, right? So here in the server, let's try to print it out whether we are able to get the DSN or not, right? So log.printf, right? So you can use the log.printf also, or maybe you can use fmt of empty dot printf also, right? So in my case, when it comes to dealing with the HTTP or something like that, then I'm gonna often use like log also, log dot printf, right? So here we can say our config, that is going to be our config, and let's try to use like this, config.dsn, right? So let's try to spin our application now. Okay, make server. Yes, so can you see our DSN is perfectly sprinting out, right? So that means our connection is ready. So let's go ahead and integrate our GORM right here, where we'll be utilize this specific DSN right there, right? So now let's try to connect our GORM here, right? So that will be our GORM and open, and the first parameter will be our driver, right? Postgres open, and here we need to provide our DSN. That is going to be that will come from our config.dsn, and after that we need to provide a kind of empty struct of the config, right? So let's try to provide that, and GORM then config, right? So this is going to be empty struct, right? So this is going to return two parameters, right? So first parameter will be our DB, right? DB connection, and second parameter will be our error, right? So these are the two things, right? So now while we are connecting our GORM, then it is giving two parameters. One is DB and another one is error, right? So let's evaluate the error. If we have any error, then we will say stop executing the application, right? So let's break the application from here, fix the database connection and come back again, right? So let's try to do that. So we will say if error is not equal nil, then we will say log fatal F, right? And we will say here we have a database is not connected. Database connection error. Yeah, this is going to be meaningful a little bit, I guess. So let's use the default parameter, and we will say a new line as well as right after that. Then we will simply pass error here. Now, if everything is going well, there is no any error, then let's try to print a log here, log.println. This is going to be this is going to be database connected, right? Then we can check it out this database object as well as. So let's try to print it out, println. Maybe we can directly use print here. This is going to be DB. Okay. Now we will spin our application when we will check whether we are successfully able to connect the database or not, right? So here, make server. Yeah, can you see database is connected, right? So it is giving some kind of object right here, right? That's really cool. All right, then let's try to remove this line from here, right? So as soon as I remove this line and it is giving error, right? This DB is not being used, right? It says unused variable DB. So where we can use that one? The similar way we have used our app, we can see like we have created our app here and we are passing it to this REST handler struct, right? The similar way we are going to pass our DB as well as. So while we are setting up our handlers from here, right? Set up handler, then you can see like our user service is being used here, right? So our user service is going to be needed our repository also. At that time, we are going to create the repository and pass it on accordingly, right? So this is how we are going to utilize that database connection. So let's try to do that. So here, let's go here in the REST handler. Here we are going to add one more property that is going to be our DB. That's a DB, right? And here, let's try to point our DB to GORM. GORM.db. Yes, right? Perfect. Now let's go to the server.go file. Here, while we are creating our struct REST handler, we're going to pass our DB, right? This is going to be DB, and DB a kind of GORM DB. And if you can see this return type right here, can you see it's a kind of GORM DB, right? So that is the same parameter we can assign it here. So let's try to assign that DB. Yeah, comma. Perfect. So now it is complying. Our database connection is hooked up properly right now, right? But here's a question. How we can create the tables? because we don't have any tables at this moment, right? If you go to table plus, right? So you can see there are no any tables, right? So though our database is connected, there we need to create the tables, right? To create the table, certainly we need to create the migration also, right? But how we can create the migration? Using GORM, right? While it comes to run the migrations using GORM, then it is giving a beautiful way to handle it, right? You no need to explicitly configure or run something out of the box, right? So let's try to do that, right? So in this case, what we need to do, we need to go to our domains, right? And we need to tweak our domain a little bit in different way, right? So at least GORM can handle that, or GORM can recognize that, yeah, that's a kind of my table, right? This is my model where I need to create a table, right? So this is the way it's gonna work. So let's go here in the domain and here inside the user. So here in the user struct, we will do a little bit modification and we will tell to GORM explicitly the certain fields are exactly, it's a kind of a special type for the table, right? So whatever these changes we are going to do it right here, it has to reflect in the database as well as. And while we are going to run the migration, then GORM consider all the special fields, like whatever we are marking that one, it will going to make these changes accordingly, right? So let's try to do that. ID will be a kind of primary key. Let's try to mark it. So here, right after this JSON tag, right? Right after this double quotation, just put a space here. Here we will say GORM, right? And after that column, then we are going to say primary key. Then this is perfectly fine, right? Because ID will be our primary key, right? And the first name is perfectly fine. Last name is also good, all right? Then email. So here, email also we are going to mark it as a kind of GORM. And after that, we are going to say this is going to be our index, because we need to create a kind of index for email also. It will going to help us to source user by email. Then we will say unique. It has to be unique because we will not accept the duplicate emails as a kind of user. All right. Then we will say not null. Right. That's all. Perfect. Then a couple of more fields we need to do. That is going to be our the verified. This verified is by default. We need to set it kind of false, right? So let's try to do that. Here, GORM. And then we will put right after this double quotation. This is going to be default false. Perfect. And user type also we need to set it, like while we are signing up a kind of user, then we will say by default you are a buyer, right? So this is the same thing we can do, right? Let's try to grab this one and add it here. This is going to be our buyer. Default will be, yeah, right after this we need to put a kind of colon also, right? Buyer. That's fine. Now two more fields we need to add, because while we are creating the table, it is always a kind of good practice to add the timestamp where created at and updated at has to be present. So that is the way we can keep track of like the user is being already, it's active or not. That is the thing we need to do. So let's try to do that. Created at will be time. This is going to be our GORM, let's say, or maybe we can put JSON. So this is on created at, and after that GORM we can put here, and this is going to be default after that current timestamp, right? Let's try to copy whole line and add it there also. This is going to be updated at, and this is also going to be updated at, right? So default current timestamp, that's perfectly fine. For more information about this GORM, you can go ahead and check it out, their official documentation, how we can provide all this property to this struct, right? But as of now, we're pretty good at this moment. So now our user struct modification is done. So let's try to close this one here, and let's go to the server here. Now, right after this database connection, right? If everything is going well, database is connected, let's try to run the migration. Right. So let's try to add some code here. This is going to be db auto migrate, and we will provide our struct, right? Which is going to be our user. So let's try to provide that one. Domain user, right? And this is the way it's going to keep track of the migration, right? So you no need to explicitly run the migrations to for your database changes, right? So if you have any changes, go here and add more field, or maybe remove one or more fields from here, right? Then when you are going to save the application, and while you are going to run the application for the first time, right, then it'll check like if there are any changes of that specific struct or not. If there are any changes, then it will run the migration, right? So now let's try to spin our application and check it out whether we have the user table or not, right? So in the console, make server. Perfect. So our application is spinning, right? Let's go to table plus. Can you see? We have a table, right? The user, right? Then if you go to the user, you can see all the fields are listed right here. ID, first name, last name, email, phone, etc. Right? So let's check it out. The property also, if you go here and open the structure, can you see here? It is added right there as well as, right? So we have a default value, right? And here also user type also default value we have. And we have this created the current timestamp, and updated also we have the current timestamp. Now we have everything ready for database integration part, right? We have connected to database, right? We have our migration, and we are passing our database to our routes, right? Now we need to put our reports on the work on the repository, right? In the next episode will be more interesting, where we will put our report on writing repositories, right? And where we will maintain some kind of technique. Maybe we can pass some kind of mock repository also, write the test cases and actual repository also. Let's see you in another episode.